Right. If I'm thinking back to second grade, maybe it was first grade. I grew up about 10 minutes from New York City, and kids always used to come up to you every single day. I don't know what this was about, but they go, "Hey, do you know what happens if you drop a penny off the Empire State Building?" And I think a bunch of you are thinking right now, yeah, it kills the person. I always heard it goes through their skull and through their whole body. Someone told me it splits you in half. The simple act of dropping this and having it under the influence of gravity, falling actually about 400 meters. We'll take a look at that calculation and see if that's really realistic. So basically, we're at an elevated position here. We'll draw the Empire State Building. Actually, I'm not drawing the Empire State Building because I'm not that good at drawing. But I'll just draw a big skyscraper. And what I know about the Empire State Building is I know the height of it. The height of it is 443 meters high. So I'm going to call that a height of, or a position of 443 meters. I'm going to call the ground 0 meters. So we have our initial position and we have our final position, and this object is going to fall from there to there. So it's going to undergo a displacement in the downward direction. Calculation-wise, let's take a look at what that would look like. Delta y. It equals final position minus initial position. Now, if your final position, it's going to be 0 meters because it hits the ground. The initial position is at the top of the Empire State Building, which is 443. So this is very important here. Our displacement, in this case, is negative 443 meters. Now, much like the horizontal direction, you said that that direction was negative. This direction is positive. And basically, you're going to find a similar thing happening in vertical motion. Much like your math class, we've got the positive direction being up and negative direction being down. And we have a negative displacement there because our object ended up a lot farther below where it started. Now, we want to take a look at how fast would that penny be going. One of the things we're going to have to do here is we're going to have to completely ignore air resistance. We're going to assume that New York City right now is a vacuum. So this object has nothing in the way of it, nothing slowing it down. We want to see what the speed would be if it were in a vacuum here. Now, the act of dropping the penny, you have to think about it. The initial velocity, it's sitting right here in my hand. It's 0, and that changes as soon as I let go. But starting out, we know that VI is 0. So as I said before, when you're doing kinematics problems, it's very helpful to make a table of things that you know, and we know that delta y is negative 443 meters. We know that VI is 0. And the rule of thumb is this: if you know 3 out of 5, you can solve for the other variables that you don't know. So let's list the other variables here. VF, that's actually the value that I'm interested in. I'm interested in the velocity that it has immediately when it strikes the ground. A lot of people go, isn't that 0 too? It's going to be 0 after everything's all said and done, but it's going to hit the ground with a very large speed, and right now we don't know what it is. We also have no idea how long this is going to take right now. All right, so time is a complete mystery as well. What is not a mystery, and what is always known, is that if we're on planet Earth, we should know what the acceleration is. And the acceleration is going to be that due to gravity, and that is negative g. So our acceleration is negative 9.81 meters per second squared. So we do have 3 out of 5. Now what I want you guys to do is I want you to take a look at those last 3 formulas that I had you write down, and I want you to try to solve for the other 2 unknowns here. Try to solve for VF, try to solve for T. Just to give you a little bit of a gauge as to whether or not you're right, this should be somewhere around the region of 100 meters per second. This is going to be, I'm going to say somewhere around 10 seconds, something like that. But, you know, it's either a little bit more or a little bit less, and that's going to be up to you to figure out. And then based on that, you could tell me your opinion. Is this penny going to kill somebody if it hits them in the head? That's going to be up for you to kind of, I guess, ponder amongst yourselves. And I'll have you submit that answer by Google form as well, just because it's always nice to read those answers. The other thing I'm going to have you do is this. We're going to see if we can take these equations, how good we are on our first try, seeing if we can apply them to try to figure out what's going on in between, because these equations do model the motion, not just here, but all along the way. So maybe I'll give you a few time values and ask you to tell me where the object is. So I want you to find delta y at 1 second out, and find delta y, let's say at 3 seconds out, and find delta y at 5 seconds out. You should have enough information to do that. You may want to make a new table where delta y is unknown. That's up to you. And then the other thing we'll do is we'll solve for VF at the same time. So VF at 1 second, VF at 3 seconds, and VF at 5 seconds. A lot of people go, well, isn't VF the final velocity when it's all said and done? And the answer is that if we define our full time windows, that yeah, it is. But when you're solving for VF, you're solving for it after a certain amount of time has elapsed. So in this case, we would have a final velocity after 1 second, or a final velocity after 3 seconds or 5 seconds. You can solve for VF anywhere in between the beginning and end of this event. So I'll have a form for you guys to submit your answers through that, and I guess that'll count as your participation grade for today. And then when you come in tomorrow, you can get started with the lab activity that your classmates will also be doing. While you're doing this, and I'll probably tell you this in class tomorrow, but I'll be in front of the screen to answer any questions you have along the way, or point out any little things that you may be unsure of. So I will see you guys online tomorrow, and hopefully this goes smoothly.